Y component is 19.5. There. How much do we get? Sorry, A minus B. How much do we get? When you do everything? When you do this calculation, brackets minus 46 squared plus 19.5 squared, then the square root of that is how much?
49.9.
How much?
49.9.
49.9. Like that? Okay. Can someone confirm?
Same answer, sir.
Okay, so 49.9. So we have the size, that's 49.9, which is just about 15, or approximately close to 15. Basically, you can say that is 15. Okay, so the other bits is, since our vector is in the second quadrant, it lies much closer to the negative x-axis than it lies the positive x-axis. The same argument we used before. Therefore, we can measure two angles. There is theta from the positive x-axis, there is phi from the negative x-axis, and we know that these angles, theta and phi, in the second quadrant, they are related as follows. Here, so we know vector A minus B lies closer to the negative x-axis than to the positive x-axis. The angle vector A minus B makes with the positive x-axis, that is theta. The angle vector A minus B makes with the negative x-axis, that is what we call phi. These two angles, theta and phi, are related as follows, just like before. Okay, so we proceed to work out phi.
Sorry, is that in the second quadrant?
Sorry?
We've established that the vector component A minus B will be found in the second quadrant.
Yes.
And you're saying the relation is theta is equal to 180 plus C.
Yes.
Is it supposed to be minus?
No, it's plus. For us to get theta, we need to add to the 180. We need to add phi. The reason why we are adding phi to 180, because we know that phi is negative. Okay, so to the 180, if we add a negative angle, it's going to give us theta. If phi is a positive angle, then it's going to give us an theta which is greater than 180. But in this case, because we are in the second quadrant, we cannot have an angle of theta which is greater than 180. So as you are going to see from our calculation, our angle phi is going to be negative. Then that negative angle plus 180, it's going to give us an angle which is less than 180 but greater than 90 degrees. Is that clear?
Yes.
Okay, you're going to see the result very soon. Okay, so basically, for us to work out phi, this is how we work out phi. Phi is the angle you're working out which is closer to the x-axis. Okay, in this case, because, yeah, like that. So AY minus BY, AX minus BX, AY minus BY is this one, minus 46, 19.5. The other one is 46, minus 46. So we, on top we have 19.5 meters. At the bottom we have got a 46. There. 19.5 meters divided by minus 46 meters. How much is that? How much?
22.97.
No, tan phi. Just divide 19.5 divided by minus 46.
That's negative 0.42.
42, negative 0.42.
Yes.
Okay. There. Then we work out the tan inverse. Just a minute. There. How much is that? How much you get?
Negative 22.97.
22.97. That is just approximately 23. Oh, something is missing. There. So we get phi as to be approximately negative 23 degrees. Then next we proceed to work out theta. So this negative angle which we have as our phi, we're going to add it to 180. Like this. Theta is going to be 180 plus phi, but phi is negative. So in that case, how much we get? 180 plus negative 23 degrees.
157.
157. Okay, so we get 157. So we see a couple of things here. A plus B and A minus B, they all lie in the second quadrant. Okay. However, when you look at the size of A minus B, the size of A minus B is 50 meters, and the angle it makes is 157. When you go to the other one, A plus B, the size of A plus B is 10.3 meters, and the angle it makes is 145. Okay. So it's not obvious. With vectors, you can see when you're doing a plus b, you would kind of like think, oh, a plus b should be greater than a minus b. But in this case, that's not what's happening. So basically, vectors have got their own stuff going on. Okay? And this is how we add vectors, like this. Any questions so far? Is it clear? Hello? Is it not clear for everyone? There's nothing much I can do about that.
It's clear on this end.
Okay, I can try to maximize, zoom out, zoom in, but basically, how about now? Basically, the only thing I can do is really zoom. I can just do zoom, that's all. Okay, so let's move on to vector b minus a. Now, when we go to the table again, well, look at vector b minus a. This is b minus a. Here it is, b minus a. The x component of b minus a is 46. It's a positive number. The y component of b minus a is, on the other hand, b minus a, the y component is minus 19.5. So this one, a minus b, is 46. The y component, that's the x component, the y component is minus 19.5. So you can see that the x component of b minus a lies along the positive x-axis. Then the y component of b minus a lies along the negative x-axis. So the x component lies along the positive x-axis, the y component lies along the negative x-axis. This means that the vector b minus a lies in the fourth quadrant. Okay? You can imagine if you try to do a small sketch where we've got a vector, the x component lying along the positive x-axis, the y component lying along the negative x-axis, then this vector b minus a is going to lie in the fourth quadrant. Is that clear?
Yes.
Okay, so you should be able to carry out that bit of assessment. So I'm going to kind of copy and paste that bit. Just a minute. So on the x-axis, b minus a, vector b minus a has an x component which lies along the positive x-axis, and the y component which lies along the negative x-axis. Therefore, vector b minus a lies in the fourth quadrant. The fourth quadrant of the xy plane. This problem here is it looks similar to the first one we solved, where we had a vector which was in the fourth quadrant, where we had to add phi to 360 degrees. Okay, I need to kind of do that. So here we are. Yeah, so here we're saying on the xy plane, b minus a has an x component. Yeah, b minus a has an x component which lies along the positive x-axis, and the y component which lies along the negative x-axis. Therefore, vector b minus a lies in the fourth quadrant of the xy plane. Next, we calculate the magnitude of vector b minus a, denoted like that as follows. So the magnitude in this case, where are we? Again, similar steps. So this is something you should be able to carry out even without studying. This process of adding vectors, it's something you should be able to do intuitively. just by following the same steps we're following, you should be able to work out any vector problem. Just a minute. So b minus a, how do we work out b minus a? Magnitude of b minus a, this one, the magnitude of b minus a. How do you do that? How do we work out the magnitude? Hello? How do you work out the magnitude?
We square the components of the x and y components of b minus a, and we square root them.
Okay, like that. So the x components of b minus a, the y components of b minus a, we square them, we add them, then square roots, like that. So when we do that, so b minus a, the x components, where is that? It's 46. Then the y component is minus 19.5. So a minus b and b minus a, things have kind of flipped. So we try to take note of that. 46 minus there we are, 46 squared plus minus 19.5 squared. And what do we get when you do that? What do we get?
We get 2,496.25.
Have you squared it? Have you square rooted it?
When you square root it, you get 49.9 meters.
We get 49.9 meters when you square root it. And that 49.9 meters, again, as we can see, is approximately equals to 50. So you see something here. A minus b and b minus a actually have the same size. Yeah, 49.9, which is approximately equals to 50. This guy here, b minus a, 49.9 again, which is approximately equals to 50, like that. Okay. The next bit is we need to work out the angle. Now, this guy is in the fourth quadrant. So we can measure the angle from the positive x-axis to where this vector is in a clockwise direction. That would be theta. So the vector a minus b, the vector b minus a, vector b minus a lies closer to the positive x-axis. Positive x-axis. The angle vector b minus a makes with the positive x-axis measured in a clockwise, in an anti-clockwise, anti-clockwise direction is what we call theta. The angle vector b minus a mixed with the positive x-axis measured in a clockwise, just a minute, I'll print out stuff, in a clockwise direction is denoted phi. These two angles okay, so here, so we've got two angles. There's an angle theta, there's an angle phi. The angle theta is the angle you measure from the positive x-axis, then you go in an anti-clockwise direction and up to where the vector is. That is what you call theta. Then there's an angle phi. The angle phi is what you measure from the positive x-axis, you go in a clockwise direction. The difference between these two angles, one of the differences is theta moves in a anti-clockwise direction. Phi always moves in a clockwise direction. So phi is always negative. Okay? Sometimes it can be positive. Especially phi can be positive in the third quadrant. In the third quadrant, it's always positive. In the second quadrant, phi is always negative. In the fourth quadrant, phi is always negative. Because one of the components in the fourth quadrant and second quadrant, one of the components is negative, the other one is positive. But in the third quadrant, both components, the x and the y, are negative. So if you divide negative by negative, you get a positive. So the relationship between these two angles is, in this case, 360 degrees plus phi. That's a relationship. 360 degrees plus phi. That is equal to theta. Next, we try to work out what phi. So we need to work out phi, the angle which is closer to the axis. So in this case, phi is going to be how much? Tan phi. How are we going to work out tan phi?
The value of y divided by x of the component.
The value, the x components, the y components of b minus a divided by the x components of b minus a. Okay, like that. So b minus a, the x components of b minus a divided by the y components of b minus a divided by the x components of b minus a. So that is going to give us how much? Let's see. Comments. The y component is negative 19. The x component is 46, positive 46. Okay, something, just a bit. And that gives us how much? And of course, we can see what it's the same, whether you, like we had before. So minus, you can confirm that, minus 19.5 divided by 46. That is still going to give you minus 0.42. With that, we can work out what phi is going to be. How much will be phi? How much will be phi?
Negative 22.9 degrees.
Yeah, which is approximately what we had before. But of course, like that. So the value of phi is the same. What is different this time around is theta, because of how we're working out the theta. So we're going to use phi to get theta as follows. 36. There, theta is equals to 360 degrees plus phi. So that is comment 360. How much does that give us? 337 degrees. Okay, so like that. Is this clear? Okay. So we have, I think we are done with question number 2. There is question number 3. Question number 3, I think the most we can do with question number 3 is probably the table. But yeah, we can try to make the table. Then from the table, we can try to kind of like continue from there. So basically, yeah. So a particle undergoes 3 successive displacements in a plane as follows. So I've put some names to the displacements. That is, the first displacement is 0.4 meters southwest. The second one is 5 meters east. The third displacement is 6 meters in a direction 60 degrees north of east. North of east. So you're going east to the north of east. So basically it makes an angle of 60 degrees with respect to the direction to east. So if we make our table, let me try to do that. For this one, we need to copy one of these tables, then we modify them. I'll do this. So we can just work out probably the components and the directions. Just a minute. So we have, what do you have? We have got vector A. Just a minute. There is A. There is B. A, B. I think there's C. 3 of them, A, B, and C. Yeah. Huh? What has happened? Somewhere there's something missing. Just a minute. Caption. Oh, sorry. Comment. Just a minute. Okay. I'm having a problem. So I think we can end here, unless there are any questions, so that I try to fix this. Do you have any questions?
No, sir, it's clear.
Okay. So I'm going to modify the invitation for the week for the 18 hours class. I will add Thursday. So be on the lookout for something in your email. Okay, accept, so that we can meet tomorrow, same time. Is that clear?
Yes, sir.
Okay, so in the meantime, I'm going to upload to Moodle the solution you've just worked out for question number 2. You check out in your vector part. So for question number 2, and also I'm going to upload the recording to YouTube and later on to Moodle. So the first thing I'm going to do is just upload the PDF to Moodle, so you can find it there. Okay. All right. See you tomorrow.